Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to General class. This episode is Sub-Element G4, Question Group B. It's about tests and test equipment, and I'm your host, Ron Call, KE7CR. Let's jump into the questions and get started. The first question is, what item of test equipment contains horizontal and vertical channel amplifiers? And the answer is an oscilloscope. Here's an image of an oscilloscope. An oscilloscope is a necessary tool for analyzing AC signals. An oscilloscope essentially measures voltage changes as a function of time. So it displays time on the x-axis or horizontal axis and voltage on the y-axis or vertical axis. So it measures changes in voltage over time. The next question is, which of the following is an advantage of an oscilloscope versus a digital multimeter? Well, the oscilloscope is able to measure complex waveforms. That's AC waveforms, where voltage is changing over time. The next question asks, which of the following is the best instrument to use for checking the keying waveform of a CW transmitter? Again, if you're checking waveforms, you're checking complex AC signals, an oscilloscope is the right tool to use. Here's an example of using an oscilloscope to measure waveforms. This shows the CW waveform. You don't want to feed the output of your station directly into an oscilloscope. There's too much power and it would destroy the scope. You need an attenuated signal. The next question says, what signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal? The way I did this video was coax connecting the input of my oscilloscope to the antenna switch. I did not have the transceiver connected to the oscilloscope using the antenna switch. Instead, I had the transceiver connected to the antenna. But there's enough stray RF in the switch that it could sample that RF and output that to the oscilloscope. So it's a way of using an attenuated RF output. Oscilloscopes just cannot handle that much power. So every time you're going to input your waveform from your transceiver, you need to make sure it's an attenuated RF output of the transmitter. Cut that power level way down, and you'll still be able to sample that waveform on the oscilloscope. So the answer is the attenuated RF output of the transmitter. Next question, why do voltmeters have high input impedance? If you think about a simple schematic, just a voltage source and a single load resistance in series, current is going to flow in the only path available through that load resistance. But as soon as you connect a meter to that load, the meter becomes parallel with the load. That's going to cause the current to split in two different branches. Some of the current will go through the load, the rest of the current will go through the meter. The voltage drop of the meter is going to be the same as the voltage drop across the load because they're in parallel, but the currents are going to be different. And if you have a very large impedance in your meter, then it's going to impede the flow of current through that meter. So most of the current will flow through the load. When you have a meter that you're trying to measure accurately to a load, it is very helpful to have a very, very large impedance. Think of something on the order of, tens or hundreds of mega ohms. Compared to your load, most of the current is going to flow through your load and allow you to accurately measure that. So the answer is, it decreases the loading on circuits being measured. A circuit loading means the meter is affecting the reading of the circuit. The greater the impedance of the meter, the less current is going to flow through that meter, so it's not going to load the circuit much at all. Next question, what is an advantage of a digital multimeter as compared to an analog multimeter? Digital multimeters are more precise. You can have more decimal places, you can get higher precision. That's the real advantage. The next question, what signals are used to conduct a two-tone test? What a two-tone test really is inputting two tones of equal power that are not harmonically related. So two different frequencies, equal power, into a single sideband transmission. So the answer is two non-harmonically related audio signals. The next question asks, what transmitter performance parameter does a two-tone test analyze? What it's designed to do is test linearity. That's the answer. A perfectly linear transmitter is going to produce those two tones and only those two tones. So if I input two non-harmonically related tones into the transmitter, it's going to transmit only those two tones. Now, if the transmitter has problems, if it's not exactly linear, you can get some harmonics generated, so you have multiple tones, multiple frequencies. The tones are produced with equal power levels, so that the only variable is the different tone or the frequencies. Now the output can be examined using an oscilloscope to see what other signals are on the output, and if you see other frequencies or other tones, you know that the linearity is not perfect in the transmitter. So that's really what you're trying to test, is linearity. The next question, when is an analog multimeter preferred to a digital multimeter? A lot of people don't use analog multimeters anymore, but if you're trying to adjust a circuit for maximum or minimum values, and there's any changes that are happening, a digital multimeter, the values are constantly changing. You'll see those digits changing, and it can be difficult to try to see exactly what the value is. So if you're adjusting just for maximum or minimum values, you can use an analog multimeter, and the needle will stay low and maybe bounce a little, but you can see what that real low value is. Same is true for a maximum value. If you're trying to peak something at maximum, the needle may stay pretty much pegged at maximum. You can tell what that is. There's a kind of a lag, a delay in the time for how fast the needle can move. So it tends to be that it shows maximum and minimum values easier than a digital multimeter. Next question, which of the following can be determined with a directional wattmeter? Well, the name, directional wattmeter, tells you what power is being transmitted and the direction the power is being transmitted. So the correct answer is the standing wave ratio, which is the ratio of forward power to reflected power. If you know what direction both the power is going, you can display the standing wave ratio. Next question, which of the following must be connected to an antenna analyzer when it's being used for SWR measurements? The answer is the antenna and feed line both have to be connected if you're going to measure SWR. If you want to measure just the impedance of the feed line, you can have just the feed line connected. The antenna analyzer also has the ability to measure impedance of the feed line. But if you want to measure SWR, you connect the feed line and antenna to the antenna analyzer. The next question, what effect can strong signals from nearby transmitters have on an antenna analyzer? Well, that could interfere with the SWR readings. Received power interferes with SWR readings. Because the antenna analyzer is basically just a little transceiver, it injects a small power, a low power signal into that line and then measures that SWR. If you have a transmitter nearby, power can be received in that antenna and affect the SWR reading. And then the last question, which of the following can be measured with an antenna analyzer? Well, again, you can measure SWR, but that's not one of the options for this question. The other option that is correct is the impedance of a coaxial cable. You can set an antenna analyzer to measure impedance and read that off of the coaxial cable that's connected. All right, that wraps it up for this section. Thank you for joining me for this one, and we'll see you in the next section.